In this video, we will learn about artificial intelligence, AI, and a brief history of its hardware and software development. Let's get started. Artificial intelligence, AI, is an ever-evolving field. Its early roots date back to the 1950s and 60s, but it wasn't until computer scientist John McCarthy coined the term AI in 1956 that it began to be viewed more holistically. Over the last few decades, we've seen various stages of AI development, with hardware, software, algorithms and services all coming together to present us with increasingly intelligent systems. This video will explore AI hardware and software development from its earliest beginnings up until now, including project details, timelines, and even speculation as to what AI might look like in the future. AI is a programming language that automates systems used to perform decision-making tasks. The key concept behind AI is the ability for systems to learn and to evolve over time. They can be trained on large data sets to become more efficient, and they can also apply what they've learned to new problems and tasks. This has led to the development of self-driving cars, virtual assistants like Alexa or Siri, and even modern medical systems like IBM's Watson Health. AI hardware development. AI hardware development spans from the inception of neural networks and computer systems, through to present-day deep learning and AI chips. Hardware is essentially the system that enables AI algorithms to be realized. Initially, AI involved large computer systems, with data sets and pre-programmed tasks. These systems were often very large, complex, and expensive. In recent years, we've seen the rise of AI hardware that's more focused on providing the processing power needed to support AI algorithms. AI hardware can be broken down into three areas: neural networks, computer architecture, and AI software. Neural networks. Neural networks are a type of computer model that mimics the way that humans think. In essence, neural networks are systems of interconnected processing units. The complexity of a neural network comes from the vast number of possible combinations that can be created through this interconnection. To a human, this may sound like a lot of jargon, but the important takeaway is that neural networks have the ability to learn. Neural networks can be trained on large data sets to learn more complex tasks. This means that they don't have to be programmed to perform tasks, but instead learn to solve problems that they encounter. Neural networks can be trained to recognize patterns, read and interpret data, and even make decisions. Over time, neural networks have been used to create chatbots, recognize objects, understand natural language, and understand voice commands and commands. Computer architecture. The second area of AI hardware is computer architecture. This can be broken down into three subtopics: computer vision, speech recognition, and natural language understanding. Computer vision is the ability for an AI system to visually process and interpret imagery. Computer vision can be broken down into two subtopics: image recognition and object recognition. Image recognition involves the recognition of objects in an image. Common uses for image recognition are facial recognition and object recognition, which includes the ability to identify objects. Speech recognition. Speech recognition is another area of AI hardware that's been gaining popularity. This subtopic can be broken down into two subtopics: language recognition and speaker identification. Language recognition is the ability for an AI system to understand the meaning of words. Common uses for language recognition are the ability to understand commands, recognize restaurant menus, and more. Speaker identification involves the recognition of a specific person's voice. This can be used to enable easier voice recognition with AI. This is especially helpful for assistants who have a wide range of commands and needs. Natural language understanding. Natural language understanding is one of the most exciting subtopics to be developed in AI hardware. It's the ability for AI systems to understand and interpret human language. Early attempts at natural language understanding relied heavily on handwritten notes and even computer-generated text. Now, however, we have systems that can understand and interpret natural language. Natural language understanding can be broken down into three subtopics: sentiment analysis, language generation, and generation of structured data. Sentiment analysis is the ability for an AI system to understand the sentiment of a text, such as whether it's happy, sad, or angry. Generation of structured data can be used to create graphs, create tables, and create other types of data. AI software development. Finally, we'll take a look at the development of AI software. AI software can be broken down into four subtopics: data processing, machine learning, visual recognition, and language generation. Data processing involves the manipulation and transformation of data. This can be used for performing calculations, manipulating datasets, creating new datasets, and more. Machine learning is the area of AI software that involves the training of AI algorithms on datasets. It's important to note that this dataset doesn't need to be visual imagery or text. It can be anything that can be represented as data. Visual recognition is a subtopic of AI software that involves the recognition of images. It can be broken down into two subtopics: computer vision and object recognition. Computer vision is the ability for an AI system to visually process and interpret imagery. Object recognition involves the recognition of objects in an image. How to achieve AI in business today. AI is a very exciting topic, and it's no wonder that so many people are interested in finding practical ways to implement it. Thanks to recent technological advancements and expansion of data, AI is now more accessible than ever before. Businesses can now create automation and optimize operations, while also adding more human element to the equation. This can be achieved through AI implementation across a variety of areas. Business applications of AI include fraud detection, customer retention, and marketing automation, to name a few. Businesses can use AI to automate repetitive tasks that take a long time to complete, freeing up resources for more creative projects. Other common components of AI systems. AI hardware, software, algorithms, and services development is a fascinating landscape. However, there are a number of other common components that are present in most AI systems. Data, the life force of any system. Data drives any AI-based initiative. It's crucial to understand the data sets that will be used and how they were collected. And, of course, data protection and security are essential. Models. AI models are created through the training of algorithms on large datasets. These models are then used to make predictions and decisions on new datasets. It's essential to create and evolve these models to make sure that they're accurate and useful. Training. A supervised model needs to be trained, while an unsupervised model can be used immediately. For supervised models, you'll need to feed them data, while unsupervised models need to interact with the data itself. The future of AI hardware, software, and algorithms. From the perspective of the hardware, computer architecture, and neural network subtopics, we've made significant advancements over the last few years. However, for the most part, these subtopics haven't changed significantly. And, as we look ahead to the future, it's important to consider the surge in development of GPUs and the rise in processing power provided by cloud computing. In terms of the software subtopics, it's important to note that we're seeing the rise of mobile devices with CPU power and the development of more efficient chips, while GPUs are the most common type of hardware used in AI hardware. It's also important to consider the development of newer programming languages, such as TensorFlow, Go, and Caffe2, to name a few. These new programming languages have been designed to make it easier for developers to get started with AI, while also making it easier to build and maintain complex models. The future of AI development is exciting and promising. We've only seen the tip of the iceberg thus far. The pace of AI development is slow, but steady, and once the technology is in place, it will only benefit from more research and development. AI will continue to evolve, and new hardware and algorithms will be developed to make it more efficient and effective for businesses. The key will be to use these advancements wisely and make sure that the benefits outweigh the costs. Thanks for watching. Please like, comment and subscribe for more. See you in the next video.